Hello guys, welcome to Composites. This is Himanshu. Today we'll be getting started with the AddPath software. We'll be planning a layup on a flat plate. As you can see the table of contents on your screen, we are going to follow the same process path during the whole planning process. First one is setup section. Let's go to the setup tab. As we can see, the first option there is import existing workspace, where you can import any existing or predefined workspace into the software from the system. Then there is option of the load robot, where you can load any individual QCar robot file into the software through the Dropbox folder provided to you via AddComposites through the email. Then there is robot cell option, where you can import any robot cell environment using that same Dropbox folder. As we can see, we are currently in the perspective viewpoint. Let's import my workspace. Just click on import existing workspace. Go to the desired file, double click, and it will import the workspace into the software. As you can see, the QCar robot file has been imported successfully, and the robot settings, TCP settings, base user plane, home parking position, everything is predefined. So this is how you import a workspace. As we are done with the setup section, let's move on to the plan section. So what we did in setup section was we imported a workspace in which it included the QCar robot file, including the robot settings, TCP settings, base user plane. You can see the workflow goes from setup, plan, view, edit, simulate, program, from up to down. Let's go to the plan section. In the plan section, we can see there is mold definition tab, which helps us to import the mold and other mold related functions, such as it explores the mold geometry into different subgeometries. It helps us align the mold with our desired base plane, world plane, robot base axis, anything. We can even attach an external axis by using mold definitions tab. We'll just look how it goes. Just click on new. Select a name, whatever you want. I'll just type flat plate as of now. Okay. Then this tab pops up, as I have created the mold file on a CAD modeling software, and it is saved in my PC in .stv format. Just click on .import from file. Select the desired file and double click on it. Okay. And when this tab pops up again, make sure to click on add in mold geometries tab. Yes. What it does is it explores the main geometry into different singular subgeometries. You can see there are now 7 subgeometries. Let's minimize this. Let's check our mold. As you can see, our mold has been imported successfully. Let's drag it upwards. Yeah. As you can see, this is our 400 by 400 mm flat plate. But at this position, to do the layup on this mold is not feasible for the robot, as it will violate its soft limit and hard limits. So what we'll do is, I'll just turn on the base plane. We have to align it with the base plane. So what exactly is the base plane? So base plane is the table height in real life conditions. In real life conditions, we place a mold on a table or something like that. So at that height, we have created a base plane. So to plan a feasible layup on the mold, we have to align the mold with the base plane. As you can see, the base plane. For that, we have to align the base plane. Let's click on flat plate, edit, go to the mold position tab, where you can see the mold reference, and we are aligning with respect to the base axis. Just click on pick. and you have to select two reference line or mold reference plane, and always make sure to turn on the O-snap feature in the Rhino, as it helps us like picking reference lines. Yeah, just pick this point, this line, and this one. Yeah, now you can see the XYZ axis, the position is as of mold's current position. So if you make the value 0, it will go to the base plane and align with the base axis. Let's just make them 0. As we can see, it's aligned perfectly with the base plane. Yeah, so now the robot can do the layup more easily, and we are planning the layup only on this side. Let's go to the laminate definitions. To plan a layup, to define, apply everything regarding the laminate, we'll see in the laminate definitions tab. Every process like selecting the boundary, defining the zero direction, everything regarding planning the whole laminate process is in the laminate definitions tab. Just click on add, and this tab pops up. We have selected the 2D and 3D open shapes planner mode. Current mold is flat plate. As you can see, we have named the mold flat plate. Just select the layup area, click on add. As we are selecting only this area, you can even follow the commands from this section. As you can see that there are, like you can see, select the surface of the mold that belong to the layup area command. It is kind of a guide to you. Just select, enter, and always make sure that that arrow is facing upwards, because that will be the direction the robot will start the layup from. Then boundary area, we are not selecting any boundary area because this is just a flat plate and we don't define boundaries on a flat plate. We'll go into that later when we'll deal with much complex parts. Then there is mesh coarseness, it's set at 2.5%. We'll let it be that way. Then there is zero direction. There are 3 methods to define zero direction. One is 3 points, then second one is surface edge, and third one is edge to edge. We'll just define by using 3 points method. We'll have to select 0 to 90 degree direction for a better reference to robot while planning the layup. Yeah, it's done. Once we are done with the geometry section, let's move ahead to the layup parameters. In layup parameters, the first option is material parameters, where we can select the material from library or we can edit the material library. As of now, the material set is thermosets, which is the default material as of now. We can even adjust the aerial density of the material, toe width, toe thickness, toe count. We'll get into that later. Then there are advanced parameters such as minimum cut length, runway length. These are parameters regarding the TCP, such as unpinch after, initial feed offset, tool tilt. This will apply in the ply which we are going to define. Then compensate previous laminate thickness. Toggle, what it does is it compensates the previous laminate's thickness into the current one. And go to home before new ply toggle. Its function is it sends the robot to the home position after each ply, just for the safety purposes. Then the MCL extension end is selected on both sides, and manufacturing access extension end is also selected on both sides. Now on to the defining the plies. So plies, as of now, I'll just select a ply for a reference. Just select it in a 0 degree. Yeah, enter. As you can see, the angle is 0.0 degree. There is no gaps. Manufacturing axis is 0 mm. There is a 10 mm of over travel just for the safety purposes. There is no staggering, and we are covering 100% of the edges of the layup area which we have defined, and there is no tool tilt also. We can even plan the plan out, but we'll just look into this tab like approach and retract tab. The first option is return motion to the next pass, where return strategy is set at shortest path, which is a linear path also. And there are approach parameters such as approach height, approach angle of the robot, retract height, retract angle of the robot. Yeah, we'll go into much detailed version later. Then there are robot speed settings, which are basically the robot's speed settings during the layup, such as runway speed, approach speed of the robot while approaching the mode, layup speed, first layer speed, travel speed, homing speed, then path acceleration. I'll just suggest the first layer speed should be lower than the layup speed. Then there are heater settings, in which the heater controller is add composites, IR or laser. Then there are two intensity modes, simple and advanced. Then you can adjust the heater intensity, first layer intensity also. You can even turn select when to trigger the heater on, like as of now it is before approach path, and trigger it off after over travel path. So yeah, these are pretty much the heater settings. Let's just select the laminate, and we can even click on plan selected, but we'll just click on plan all as of now. Plan all, it's generating frames, and yeah, planning is complete. As we are done with the planning section, let's move ahead to the view and edit section. As you can see, in the view and edit section, we can see our laminate 1, and under it there is a one ply which we have defined, which is in 0 degree. Let's see what options do we have. Click on laminate, right click. First option is show laminate, which shows the laminate within the software. Second one suppresses the laminate process within the software. Third one displays the mold. Show layup area will show the layup area that we have defined on the mold. Then the show boundary area will show the boundary, but we haven't defined any boundaries on this flat plate. Flip direction will flip the directions of the laminate, and edit laminate will let you edit the laminate from here also. Let's add some plies for reference, -45 and 90. So we have added 3 plies just for reference. So guys, just a quick recap of what we have done until now. First, we imported a workspace. In that workspace, there was a robot file with which everything was predefined, like the TCP settings, base user plane, and the robot settings. Then we imported a mold, which I created on a CAD modeling software. Then we aligned it with respect to the base axis for the visible layup process. Then I selected the layup area and defined the 0 direction. Then I defined the ply on 0 degree with no gaps, no manufacturing access, 10 mm of over travel, 0% of staggering, and it was going to cover 100% of edges. Now we have defined 3 more angles, 3 more plies, which are in 45 degree, -45 and 90 degree respectively. So let's move ahead. I'll just turn on the show ply option on these 3 plies. Let's go to the ply 1 and see what options do we have. The show motion path option will let you display the motion path of what the process will. Then show frames will show the frames, like how the frames will be during the layup process. This will be the steering radius of the robot during the layup. It can also display gaps, and these are the pass numbers, like how the robot will pass during the layup. You can even flip the tape order, and you can even edit the ply also from the edit ply option. So yeah, this is all regarding to the view and edit section. So once we are done with the V1 edit section, let's move ahead to the simulate section. We are in the simulate tab where we can see jog robot, home position, TCP position, more information and simulate layup options. First one is jog robot. We can jog the robot in 6 axes provided by the manufacturer. You can even see the jog mode. There are 4 jog modes. First one is axis joints, second one is Cartesian tool, third one is Cartesian base, and fourth one is Cartesian world. We'll use axis joints as of now. Then there is home position settings, where you can set any home position according to your desired needs. Let's suppose I have to make this a home position for now. I'll just click on set current, yes. And if I choke the robot anywhere else and I click on go, it will go to its defined home position. Then there is a TCP position option where if I click on show in viewport toggle, it will show information regarding the TCP in the viewport. And if I turn on the trace TCP toggle, it will trace the TCP during the layup process. If I turn on the show TCP, it will show the tool center point in the software. As you can see, it's displaying the TCP point. Then there is more information where you can see the TCP speed and simulation time while we run the simulation in this tab. Then there is simulate layup tab where we can run the simulation of the whole planning that we have done until now. So if I just click on play, it will run the simulation and the robot will start the layup process. I can even adjust the animation speed. You can see. I'll just pause it for now. We can even go into individual frames by using the frame slider. And if you want to go to the default position at the first, you just have to click all frames and then refresh, and the robot will go to its default position and it will start the layup from the beginning. Then there is a collision option. If the robot collides with something, then the robot will turn red, robot's color, because we have set the red color as of now. Then there is analysis tab where we can run a quick analysis of the whole planning process, whether the robot's violating any hard limits or soft limits. We can check through this. Let's run the analysis. It takes some time. The analysis is done. Let's check the results. There is warning of large rotation of the tool around TCP-Z. It has also provided us the frame number. You can go to the frame number and you can check whether there is something wrong with the robot. After the simulate section, let's move ahead to the program section. In the program section, as we can see, the first option is save location, where there is first option as file name, where we can edit the file name as we desire. Then there is save to, which is basically the location where we want to save our program in the system. Then there is post processor. I'll just load a custom post processor. Just click on load, select the post processor, and it will load the post processor into the software. As you can see, my post processor is loaded successfully. Then there are program settings, where first option is override TCP, which overrides the tool center point while saving the program. Second one is override base, which overrides the base position while saving the program. And third one is ignore simulation errors, which ignores all the simulation errors faced in the analysis while saving the program. Let's generate the program. Okay. As you can see, the program is loading. It takes some time, depends on the program size. Yes, it's done. Click on yes. As we can see, the program is in Puka Robots KRA language, and there are some certain parameters that we can visualize, such as layer program, initialization of program. Then there is laminate 1, total layers 4, which are basically our plies that we have defined, 4 plies. Going to composition, we can visualize certain aspects of the planning process. Hope the session was helpful. Thank you guys. Subscribe for more such tutorials.